All right, if you like, I can go through all of the sample motors that I have, but this is the best of the worst for the chicken plucker application. This one's made in the United States. And let me point out a couple of features of note. So, it's very typical in the United States. Just kind of like CE mark is in Italy, made in the USA. The UL CSA mark. Here's the winding, or the wiring. High voltage, low voltage. Part number. Suitable for operation in inverter under 208 volts. Total in enclosed fan cooled, Class F insulation, 3-phase. KVA code K. Max ambient temperature 40 degrees Celsius. Continuous duty. The warnings. So this is just a sticker. We always use a stamped or laser etched nameplate. Moving to the terminal box. You can see that it's had some corrosion. It's made out of pressed steel. There's no real effort for ingress protection. The connections are, what do you have here, 9 leads, but the connection between the terminal box and the stator has been sealed. I don't know if it's an epoxy. It seems to be hard. It's not soft like a silicon. So if water was to get in here, no problem, it doesn't get inside the motor. And clearly water has gotten in here. Screws are corroded. Just a sheet metal screw there. Power was entering through here. And this is an option that wasn't used, it's just plugged. But this is maybe an IP, maybe an IP54, maybe a 44, I would say, on this terminal box. Okay, now this is a piece of steel, mild steel of some kind. It's been rolled and welded to form this tube. You'll notice the sealant that went between the face and the bearing carriers, covers. There's no corrosion at all in the stator. The winding is fine. This motor didn't die in service. I don't know why they removed it. Here's the back side, or yeah, this would be the back side where the fan shroud was. And there's corrosion noted here. With the stator, not enough to get the stator. So there's a band of corrosion. I'm guessing condensation, because this hard part line, and that it's almost as if I think this was maybe painted or something. There's our connections from our leads to the stator. This looks like some just little plastic boots over those. All the leads are numbered though. It's on the wire. It's printed, there's no additional tags. It's just the wires have numbers. Okay, so that's the stator. Here's the fan. Notice this little concave area. Interesting. But they mounted the fan very close to the end cap. Here's the end cap. So they mounted this very close. It had a very low profile. All right. Have these little slots for where you can, the rods that hold the covers to the stator. And this has just got a screw clamp. And you can see the trash. Now, in further studying the rotor, from where the fan mounts is here, it's stepped, but it's also highly corroded. You can see that. You can see where it's worn. And then it has this little slot on the end. I don't know what that's about, but it's interesting. It's much smaller. I would say it's a 6203 bearing there on the back side, but I would say that the fan probably spun a few times on the rotor and just corroded, but it didn't get into the rotor of the stator. So this somehow worked. Here's the seal on the back side. You can see it's pretty worn. I suppose when that rusted, the seal running on that rusty shaft didn't help. Here's the bearing. See if I was right with it, a 6203. Yeah, 6203 2RS. But that's in a, there's some kind of pot metal cover. There's no O-ring seal or anything, it just was glued. This is the surface area. It was glued to the end of the motor. I guess it'd be on this other side. So this is sealant. And the rods pass through. I suppose where the rods went through could be a place of potential ingress. This is like a soft, maybe a silicon compound. Here's the fan cover. This is in formed stainless steel, inox. Nice piece. It seems to do better at keeping feathers out than some of the other motors, but that's clearly, it's had feathers and grime in here. And then this fan kind of mowed through it, but it's much more robust than our fans, our standard IEC fans. It's a short, thick fan blade. It seems to have done the job, but it's interesting that they went with a 203 on a 6203 on the back side, on the non-drive side, just to support the fan, I guess. And then here in our rotor, you see they have tabs instead of pins like what we do, the European design. And then the bearing itself on the front end, on this one, is a, I believe a 6306. So it's going to have considerable overhung load capacity. And you notice the shoulder here, and then it neck down is interesting. That's a big piece of material to turn down to make it. Then this front cover is cast iron, and the screws go tap into that, it seems. Yeah, so the rods from the end cover tap into the front cover, this cast iron front cover. Now, that's of note, the B14 mounting studs are not drilled through. I looked at competitors, the tick top they drilled through, that was where the water came in. And this bearings are fine on this motor. This is the cast iron B14 flange. And yes, it's corroded. It's got an end milled key. You can see where the key is wallered out. That's an official Oklahoma Ozark term for what happens to a key when it's cut with a key cutter instead of an end mill. So the shoulders have failed, but and it's drilled and tapped, which is unique for an American-made motor. We don't do that here. This is the slinger ring. So this slinger ring is turning with the rotor, and that's what's protecting the seal, and that's what protects the bearing. And that's that in this the non-drilled taps, non-drilled through taps, and the sealed covers, and the sealed terminal box is what I believe have kept the moisture out of this motor. But you notice the length of this shaft, this rotor shaft, is a bit short, but it's fine in this case because they're not mounting this into a gearbox. There's a gear that mounts here, a pinion gear that drives the other gears in the chicken plucker. So apparently this is exposed, so it corroded more. But this is the best of the worst, and the stator in this motor is fine. The bearings in this motor are fine. It's the winner of the losers. So I can look at the other motors, but it's just a different approach. It's an interesting way to balance a rotor. Look at this. I don't know what that's about, but that's strange. Smooth. So you can clip the tabs on the back side, but on the front side it's just this. But this is very competitively priced for what it is. I mean, the retail is not much more than my wholesale.